This illustration here you're looking at is taken from the fifth assessment, that's 2014, of the IPCC. And this demonstrates the computer model science behind the fact that carbon dioxide is practically forever. It's the percentage of an initial atmospheric CO2 addition to the atmosphere that remains in the atmosphere in response to an idealized instantaneous CO2 emission pulse. So here you have the instantaneous pulse of CO2 in the computer model simulation, and the model follows the rate of decline percentage-wise of that pulse in the atmosphere. So here it's 80% left, here's 60% left, and 40% left, and so on. This goes from 0 years to 100 years here, and then from 200 years to 1,000 years here. Of course, the percentage of this initial pulse remaining in the atmosphere relates directly to the concentration that would remain in the atmosphere. And there are computer models with the same kind of results as we're looking at here for atmospheric concentration. Now, I've simplified this original illustration here from the IPCC, so I just point this out. There are two graphs here, two projections from the computer model, and the upper one here that I haven't shown is a very much larger pulse of CO2. Now, relative to the increase in the original CO2 pulse, there's a lot more CO2 remaining in the atmosphere at 100 years and at 1,000 years. So at the end of 100 years here, there's still 30% of the carbon dioxide remaining. And at even 1,000 years, there's 15% of the carbon dioxide remaining. So even at 1,000 years, 15% of the initial carbon dioxide is still heating the oceans, increasing the temperature of the lower atmosphere and the surface of the planet, and acidifying the oceans. Hence, this confirms the ultra-long lifetime of a CO2 emission in the atmosphere. The effect of that emission lasts for a long, long, long time. And in human terms, human society terms, it's practically forever. Here's a very basic animation done with the PowerPoint of this IPCC AR5 fifth assessment graph of a model simulation of an instantaneous pulse emission of carbon dioxide into the atmosphere, and then the model following the declining concentration of carbon dioxide in the air, showing its ultra-long lifetime in the atmosphere. Here I've modified that IPCC AR5 graph to fill in the area under the atmospheric CO2 concentration, and that immediately makes it more obvious that this is representing the atmosphere, so you can see more clearly the decline of the atmospheric concentration in the atmosphere. I've chosen to fill it in red because the atmospheric CO2 concentration correlates directly with the amount of heat that the added CO2 has added to the lower atmosphere and hence the surface of the planet. So we can just play a quick rough animation of that. Here's the final and most important point and variation on the IPCC AR5 graph. Here I've filled it in a violet, and it represents now the ocean instead of the atmosphere. So with our computer model correlation of what happens to an instantaneous pulse of CO2, 15% of the carbon dioxide in the oceans this will be a direct correlation. This will be a direct correlation with the CO2 model because of course, CO2 emissions and increasing atmospheric CO2 concentration directly causes ocean acidification. And so the big message here is that global climate change and global surface warming with respect to CO2 is not the only thing that is forever. Ocean acidification is forever.